So welcome back. My name is Saptak Sen. I'm a Senior Product Manager in the Azure Data Platform team, and I have with me Bill Ramos.
Hi, I'm Bill Ramos. I'm VP of Consulting Services with Advaya, and I'll be doing the demos for this module.
So in this module, we are going to cover how do you operationalize your big data platform. So we are going to look at various options using PowerShell, using Web HCAT, and Web Hdfs. And we are going to, as we go along, we are going to describe some of those in much more detail. So let's get started. So we do have our .NET SDK for Hadoop. And what that lets you do is to, some of the things we covered in our first module on how to, submit a job and so on, you can now do that from your code, because it's important to be able to do that from your client applications. And that's what the .NET Client SDK provides. So we saw in a previous module how to write MapReduce code in .NET, but we didn't see how to submit a job or monitor a job using .NET. So that's what we are going to do. Now, in the last module, you saw some of these aspects play a little bit, like the Hive library, the web client library, and this lets you submit, for example, Hive jobs, right? And also, when you're using link to Hive, you are still going to have to use the Hive library. Now, using that, once you submit a particular Hive job or a MapReduce job, what the MapReduce framework does is then it generates, as usual, a MapReduce job for the Hive query that you have submitted, and then it runs it. Now, Web HDFS and Web HCAT provides something a little bit different. Now, Web Hdfs, as the name suggests, is a REST-based API which lets you move and deal with files on HDFS. Basically, it lets you do file and directory operations. Whereas Web HCAT helps you schedule jobs and manage the executions of jobs on your cluster. Now let's look at a demo where we see a .NET application being used for submitting a job, actually to submit, move some files on using Web HDFS.
Yep. So in this demo, what I'm going to do is we're going to use the Web Hdfs API, and we're going to take the data that we used in the prior module that we generated from reactive extensions, where we had the crime data that had crime percentages greater than 100% as a text file. And we're going to take that, and it's going to get, we're going to create a Hive table, and then move the data up, load the data into the Hive table, and then go ahead and execute a query just to make sure that that all works. So let's go ahead and get started with the application. So I'm going to go ahead and create a new console app, and we'll go ahead and call this demo Hive. And as before, what I'm going to do is I'm going to load in two packages. One is the web client, and I'll do that through our tools manager here, library package manager, and then back to the console. And so this is loading both the API information for HDFS, Web HDFS, and the Web HCAT. So we've got that, and we'll bring in our other one here, which is our Hive module, because we're actually going to be doing some Hive programming. Okay, so now we're set up with our references. The next thing I need to do is go ahead and bring in my program file and walk through this. Actually, I think I'll walk through it by actually executing it, because it's a very serial program here. But I do need to make sure I get the code right. So there we go. Okay, so this example is based on one that's in the SDK to get you running, but we've set up our own parameters with the storage account name and everything like that. So I'm just going to go ahead and set a breakpoint, build the project, and we'll start. Okay, so the first thing we're going to do is we're going to set up the variables for our account execution. We're going to use our storage account that we did and then the long key that we had for the information. We'll then go ahead and establish our cluster name, our admin, our Hadoop user account and password. And then our student variable is going to be used to set up a variable with the result file. So we're going to create a Hive table that's essentially going to be called 01_crimeinfo.net. And so we'll go ahead and do that. The other thing we're going to do is use our student ID to set up an output directory for our result in our Hive table. Set up our Hive table name. So if we look at that there, we'll see what's going on. We're going to indicate where the container path is. The next thing we're going to do is show where the file is on our hard drive. And so this is where Web HDFS is going to locate the file and then upload it, and we'll set our file location. Because Web HDFS needs our account information, we go ahead and set up our storage account and our container where we want the result, and then finally we specify the URI, which in this case is going to be http:// our big data jumpstart cluster. And first thing we do where we actually call out to the API is we're going to set up our storage account adapter. And when that comes back, we now have our storage account adapters set up. And now we're going to set up our client, which combines the two together for performing the operations. The next thing that will happen is we're going to create the directory based on the value here. So what's going to happen, what is it? Let's see here, boink. Oh, there's a directory. I can zoom in here. There we go. What we're going to do is create a directory on our Hadoop file system on Azure Storage, which is going to be set up for our table name. And we'll do that through this operation right here. So I'll go ahead and F10. And so our directory is created, and we'll write that out to our console window. So that's letting us know we've gone through. The next thing we're going to do is actually copy the file, our local file, from our directory, and we're actually going to put it in our output result and give it the same name on the HDFS directory. So we'll go ahead and do the copy file operation. So right there I showed how you can use the Web HDFS client to actually copy a data file from your local hard drive to your Azure storage without, in the past I've been using things like fsput, or we've been using utilities like the Azure Storage Explorer, but with this library I'm able to copy the files from my local hard drive up to the system without any issues. So if we go back to my example here, the next thing we're going to do is set up a Hive connection. And so what this will do is go ahead and set up all the information needed to connect to the cluster with the appropriate usernames and passwords and account information to create our Hive table. So we'll go ahead and create a Hive table named 01 crimeinfo.net. Okay, we're going to go ahead and we've got a string variable with our command that we'll go ahead and set up here. And so this will go ahead and essentially do a create table statement with our state, city, population, total crime activities, and our crime percentage as a string. We'll indicate that it's delimited by commas, and it will be stored in the Hadoop file system as a text file. And we'll add into the command the location of where we're doing it, in particular the same path that we had before. Actually, we have a different path for our table itself. We'll go ahead now and execute the query that will create the table statement. And so this will take a little bit as we're sending out actually to the Hadoop file system the create table statement, and so we're going to wait for that to come back. And so hopefully that should happen here in about 10 seconds or so. Let's see what happens. So go back to our display here for a moment. Hopefully this moment will go quick.
Right.
It's a good thing I had a display in the command window of the create table statement,
right,
so we can look at it there.
Right.
So again, what I'm using, whoops, let me go back. I just want to point out here, when we're executing this query, we're using the wait method here. It looks like it finished. So we're saying execute Hive query, and we're telling it to wait. Again, if I forgot to use this wait method, what will happen is the load data procedure, which is down here before, would execute right away, wouldn't have a table, and everything would error violently. Well, in the way the code errors, I guess.
Right.
Okay, so now that our table's created, I'll go ahead and we'll load the data into our system. And again, similar to what we did in the Hive module in module 3, we're using the load data statement where we're indicating the container where the data is going to come from, and this is the crime data file that was uploaded using the web Hdfs API. And now we're going to go ahead and load in the data. Now this should not take too long because we have, what, about 10-15 records in there. Again, this was from our reactive extensions example where we looked at crime data that was over 100% for cities. So we didn't have too much data, so it shouldn't take too long to load.
So in short, Bill, the wait method basically helps you, make this method synchronous instead of asynchronous, right? You by default, these are asynchronous methods. It returns right away as it submits, and it's useful for most situations because you can go do something else and then come check back to see if your results are back yet or not at a later stage. But in some cases where you do want to wait for the query to finish, those wait methods provides you a way to kind of make those methods synchronous.
Yeah, in a way, it's you debug your code with these wait methods,
right.
Because I'm just showing a very small fraction of the API, but there's a way to actually, once you go ahead and run your queries, you can actually, it gets scheduled up and you have a way to see what's going on with your system. You can actually tell these when you execute when you want it to run, and the Hadoop file system will take care of all that activity for you. Well, we're back. The data's all loaded up now. And so now we have a data file or a Hive file in theory that's ready to go. So what I'm going to do is go ahead and we're going to issue select query. We're going to select star from our Hive table, and then like we did before, we're going to do the execute query command. Now, I'm a little bit hesitant why I didn't have a wait on that one, but we'll see if the results come back here. Ah, I know why. Because what we're doing here is, this is another way, what we're doing with this results or result.result read to end, it's taking the data that we had from the execute and it's actually waiting for the stream to come back. And so this is another way that you can wait without having to do the wait method for viewing your data. So when all the data is finished, it'll go ahead and output the results to our console here, assuming all goes well. So there's different ways of waiting for stuff within the .NET API here.
So the underlying thing is that Hadoop is, again, a batch system. I know we have told this several times across the different modules, but this is just kind of showing it that how much of a batch system it is. But what it buys you, this batch system, is to do all these arbitrary queries over your arbitrary data set. This could be text files, this could be image files. You'll have to obviously have, if you have special kinds of files like image files and so on, you need to have specific serializers and deserializers, and these are some of the advanced topics which we won't be covering in our current course here, but there's plenty of documentation, and we are planning some white papers and so on around those advanced topics, so look out for those.
So we're back. Our results are back. So if we go back to our console here, you'll see we now have our results back from our Hive query. So essentially what we've done is we've taken the text file, we used the WebCat, the Web HDFS feature to take that data file, load it up onto our Windows Azure storage, and then from there we went ahead and created a Hive table and loaded the data from that local file into the system, and then did a select query to show our results that we see right here for our data result. So we'll go ahead and continue out and press any key to continue. And that is it for our example of running a Hive query using the WebCat function. So with that, I think we have one more demo slide. If we switch back to the slide there, we'll show out what the next scenario is here.
Yeah.
Actually, if you go back one, please. Now we're back two. Okay. So in this next example, what I want to do is show how to use Web HCat for actually performing another job, where we're going to do, again, another Hive query for that. So let's go ahead and run that get that example up and running, I think. Did I go too far? It's not a rhetorical question. Let's see. Select. Okay, here we go. Good. Okay, so in this next example, I'm going to create a new project, and I'll call this HCat. And I'm going to go ahead and get rid of my text there and bring in the new application program. I'm suffering from mouse ability here. Okay, so I got that text. And then you see here we're going to be using actually a combination of Web HDFS and HCat to get things going here. And what I need to do now is import our modules. So I'll go ahead and go off to NuGet. And we have all our dependencies resolved. So again, let me go ahead and just do a quick scan here, make sure I have everything set up. Okay, good. Set our breakpoint just to run through the application and let her rip. Move our console window over here. So similar to what we did before, we'll go ahead and set up our variables for the username and password. Identify the Hive table that we're going to be working from, and then set up our cluster URI and our output directory where we're going to have the Hive results queries go. So in this case, we're actually going to output the data from our Hive query into a file that we can later read. And we set that establishment. And the next thing we're going to do is set up our HCat HTTP client. Now again, I'm using C# code. There's a complete REST API that's available for this as well, so that you can use anything to actually make these calls. So now we're going to go ahead and create our remote Hive job. And we're going to go ahead and do a select from our Hive table. And at this point, what we're doing is we're going to go ahead and, as part of our command, we have our select statement. We're going to indicate where our output directory is, where we're going to be able to see the results. And so essentially what we're doing is creating a Hive job. We could have created a MapReduce job and a pig job using the same HTTP client as part of the operation. So this is just the one API that we're using to be consistent with our examples with Hive. So now I'm going to go ahead and execute or schedule that up, and we're going to wait for the Hive job to actually come back. And so at this point, we're now going to go ahead and just show again how you would see asynchronously what was going on. Now again, not the best program to check for asynchronous stuff, but what we're going to do is go ahead and wait for our job results. So now we've this is our job ID. If I was to go back to the console that we had on our HD Insight cluster, we could actually see this job. This job would also allow us, there's an API for killing it, so if we have a rogue job that gets spun up, we have a way of making sure that you can actually kill it based on this job ID. Okay, so our job is now complete, right? And so now what I have with my result is execution of that. Let's go ahead and go back. And I could go back and actually see the table results in the output directory that we had there. So with that, I'm going to turn it back over to you for our PowerShell example.
Okay. So what we just saw is the ability to manipulate files and manage files on the cluster using the Web Hdfs API, which is again a completely REST-based API. And then also how to submit jobs, manage jobs on the cluster using the Web HCAT API. Now this is great if you're using something like your .NET code, but for most system administrators, they prefer the flexibility of PowerShell. So for PowerShell, we have created a bunch of commandlets which you then can use from your PowerShell environment to do some of this as well. So again, moving on to Bill and see how that works again.
Okay. So in this demo, what we're going to do is take you from beginning to end how to set up your PowerShell environment to work with Windows Azure, because it's really not as simple as firing up your PowerShell, start doing the commandlets and things like that. What you have to do is actually set up authentication through a certificate that allows your client then to communicate to Windows Azure, and particularly the HD Insight cluster. So we're going to go through and run through a complete cycle of setting you up, creating the certificate, setting up the subscription information, and then once we have that set up and tested, we'll go ahead and run this really great PowerShell script that was created by a gentleman named Carl Nolan, who's a principal consultant out in the UK, who's been working with us quite a bit. He set up a framework that allows you to run a MapReduce job, essentially create the cluster, run the MapReduce job, and then tear down the cluster when you're done. So it's a very nice framework that'll show you how we actually will do that for running our original MapReduce job that we had created way back in Module 2. So let's get started on that. And so go back to my cheat sheet here. And the first thing I'm going to do is I'm actually going to create my new mapper reducer job within the system. So I'm going to go ahead and say new project. And the thing that I'm going to do a little differently than the last time is I'm actually going to create a class library, because the end result, I want this to be a DLL that will have our mapper and reducer classes within that single DLL that will be used to execute the MapReduce job within PowerShell. If you recall, last time in Module 2, we actually created two exes and use the C# streaming class, but now we're going to use the more traditional way of creating a single class using .NET that includes both our mapper and reducer. Okay, so go ahead and I'm going to give this a name. Again, I have to be very, we'll call this census data. And we have our definition file here. And I'll rather than walk through the entire program, I'll kind of show you what's different between the prior versions that we had here. Okay, so we have our code, and I need to add in our imports here. So again, I'll go off to our tools, package manager, console, and we'll bring in our MapReduce library. Okay, no red squigglies. That's always a good sign. Okay, so the key things that are different here is we still have our map routine, which is essentially, again, taking our input file and splitting it out to the words. We're doing the same translation that we did before, and then writing out our key value, which will be, again, the specific chunks of data that we have here, plus the population value. And then in our reducer, we're actually using a slightly different chunk of code where we're going ahead and taking the inputs and combining them and using the sum value that will go ahead and do the sum of the population value. So this is kind of the main change that we did here, where we built out a reducer and combiner class for doing the processing of the data. Okay, so I'm going to go ahead and I'm going to, let's see, rename this to census data. And we'll go ahead and build it off. Now, just to make sure that everything is in place, I'm going to go off here in our applications and census data, in our bin directory and in debug. You see, rather than having an exe, we now have a DLL. And this DLL will be used when we execute the MapReduce in PowerShell. We're actually going to set it up to use reflection to get out the modules for doing the execution for the MapReduce job. Okay, so now that we have our MapReduce program in place, it's now time to talk about PowerShell. And so let me go ahead and scroll down here. Okay, now the first thing you need to do is actually download the PowerShell SDK. I'm going to go ahead and copy this to the clipboard, and we'll bring up a browser window. Again, all this will be in the documentation that we have for the SDK. Now, the steps that I'm going to do are pretty much the same steps that you're going to see here. So I've already installed the Azure PowerShell or the Azure PowerShell tools. That gives me the Azure PowerShell console. So if we scroll down here, this PowerShell is not the general one. It's one specifically set up for Azure that has the appropriate Azure commandlets configured. The other thing that we need to do is download the HD Insight commandlets. And so when you do that, I do want to point out one thing, that we're downloading this file from the internet. And I'm going to go ahead and save it, do a save as, and put in our download directory. And I'm going to just change it a little bit here in the zip file. Now the reason I show this is that when you go ahead and download these and unzip them, PowerShell is very sensitive to security and where you got your commandlets. And so one of the things you need to do before you unzip the file is you need to go down here and bring up Properties And you'll see here that this is a security warning. Normally you wouldn't see this on zip files that you create yourself, but what you need to do is unblock before you unzip. I don't know how many times I've unzipped these commandlets without unblock and then go, why aren't the commands working? So I wanted to point that out before I did anything else. Now I've already got the commandlets set up and unzipped, but I just wanted to show you once you unblock it, you're able to unzip them into a known location, and then you can go ahead and use those commandlets within your PowerShell script. Okay, so we've now, what I've done is taken those commandlets and already done the operation in our applications directory, and I've unzipped them here. The main one that we're going to worry about is the hdinsight commandlet right here. Everything else are supporting commandlets. Okay, now next thing we need to do is set up our certificate. And to do that, what I have to do is go over to Visual Studio and bring up the developer command prompt for Visual Studio 2012. And what this allows us to do is run the make cert routine for creating a certificate that's going to be used to establish our security mechanism between our client and Windows Azure. So what I'm going to do is show you the command here, and I'm going to modify it just slightly because I've already created these certificates. But I want to go ahead and just show you what you do is you specify the certificate name, and in this case I'm calling it BD Jumpstart 1. These are all the parameters for making sure that you have the right encryption and encryption key length. And then the certificate file is actually going to go into, because we were using the my switch right here, what this is going to do is load into your certificates under current user personal certificates if I was to go in to Cert Manager and do that. So let's go ahead and run this. And it said failed. Why did it say failed? Actually, this step we can bypass here.
Could it be you already have that?
Could be. I don't think so here. Oh, I know what it is. Okay, what it is that because I'm creating a certificate, I need to run this as administrator. So what I'll do is I'll go back here and I'll say run as administrator.
You're doing it live.
We're doing it live, baby. Okay, so let's see if we got this in our paste buffer here, and we'll go ahead and add our one here and our one here. Succeeded! Yay! Okay, so again we have to run this command as administrator to go ahead and make our certificate. Now that I have our certificate, what I need to do is upload that to Windows Azure. In fact, let me just do one more thing here where we go run, and I'm going to run our certificate manager right here. So I'm going to run the certificate manager snap-in and just show you that I'll now have two certificates, BD Jumpstart and BD Jumpstart 1. Now, the interesting thing is that those particular items are actually located in your Windows folder. Go here now, and if we sort by date modified, you can see our two certificates, the one that I created first time and then the second one that I just created now. I now have my certificate set up. So the next thing I have to do is actually upload those to Azure. And so let me go ahead and shut this down and shut that down. and open up our portal. Already logged in, so if we go down to the bottom here, this little gear shows settings. And by clicking on settings, I see my management certificates, and these are the things that are used to actually connect up the different clients. And so we have a whole bunch of them here already, because this kind of shows you there's one that's been created for each time someone's tried to do any PowerShell demos within the Azure account that we set up right here. I'll show how to do the upload, but I actually, let's go ahead and do this and hope it all works. So we'll go ahead and go to our WoW directory. And actually want to do star.cer.
Get modified.
I guess I could have typed it in. There we go. Go to our certificate here and click OK. And then when I click OK here, it'll actually go ahead and upload it. So it's taking the certificate, decoding it, building out a public key value for it that I can use later on for actually doing my connection. And so while that's loading, we now have our Jumpstart 01 certificate created. Okay, so now we've set up a way to do our connection between our client and, or we're almost set up with our connection from our client to talk to Windows Azure with PowerShell. So if we go back to our screen here, what I need to do is do a series of commands to extract our certificate information. So I'm going to go ahead and run those, and I'm going to bring up our, again, this is the Windows Azure PowerShell command. I'm going to go ahead and run as administrator here. And rather than run these, because I've already run them once, I want to make sure that the demo works. But what you would do is, I'll go ahead and zoom in over here, is, again, this is kind of a one-time deal where you go ahead and get your published settings file. This downloads an encryption or encrypted file that you can go ahead and it's actually not encryption. It's actually the key that's available for your information. This is what you use to establish the security protocol. And then what you do is you do an import operation of the file that you just generated, and this sets up everything. I'm going to skip ahead actually to do the get subscription information, because in theory this should be set up for my other item. And if this doesn't work, then I'm going to go back and do these 3 steps. So let's go ahead and paste this in here. And we see here that we have our subscription information based on the one that I already set up for. So I'm just bypassing a couple steps just to expedite things to show that we have our Azure security subscription. And so this, if this works, then you know that you had done these steps right to import your, to get your published file, import it onto your hard drive, and then set up, do the import Azure published settings. Okay, next thing I'm going to do is go ahead and change directory to my applications folder, and I have to now import our HD Insight cluster management commandlets. Now I'll presume that once HD Insight goes general availability, that these commandlets will actually be incorporated as part of the whole Windows Azure suite. So eventually when we go into general availability, I won't have to do these extra steps, and hopefully Sopdeck's concurring and is going to talk to the product team and make sure that actually works, right?
Yeah.
Okay, so what I'm going to do now is I'm going to import our modules. So again, this is standard import module clause. We indicate the path for our commandlet. And if all goes well, we see our the various commandlets that were imported. And so we have commands for creating the metastore. This metastore, let me kind of walk through each one of these. The metastore is used for the Hive and the Uzi data store, where I can actually tell our cluster to use a Windows Azure SQL database for the metastore. We have a commandlet to add a storage account to the system. We have this is going to be one that we're going to use where we're going to go ahead and create a new HD Insight cluster. We can set up a configuration for it where we actually tell the cluster how things are going to be configured. We remove the cluster. That's another one we're going to do. And then you get we can get cluster information, and along with that, set up a default storage account for our cluster. If you recall, in the very first module, when we set up our Windows Azure cluster, we indicated where we wanted our default storage for that. In this case, in our case, it was Hadoop root. Okay, so now that we have our commands ready to go, we need to do a couple quick checks to make sure everything's running. Because if you if you didn't follow the setup certificate things correctly, even though it looks like you can get some of the information out of the system. So for example, when we did our Get Azure subscription, everything looked great. And so what I'm going to do is I'm going to take this command and paste it in. And so what this is doing is getting our current Azure subscription information here. Again, this looks very similar to the output that we did before. And we're going to get a couple of variables out of this. We're going to get cert name, the sub ID, and the name of the subscription. So go ahead. So now if we take a look, for example, at our cert, this is our certificate information, and our sub ID. These are actually things that we need to do to run the get cluster command. With these two bits of information, we can go ahead and get our cluster information. So what I'm going to do now is run this commandlet here. So what we're going to do is run get Azure HD Insight cluster with our subinfo and our certificate information, and with that, we're going out and getting all our clusters. Now, the fact that this thing worked means that our big Mongo PowerShell script to do the create cluster, create the MapReduce job, run it, and then destroy the cluster is all going to work. So now I'm in a really happy state right now for completing this demo. Okay, so now that we have that in play, we're ready to actually run our big file here. So what I'm going to do is show you, and let's zoom out a little bit. You zoom in, let's get this. Okay. And I think to make it easier to read, I'm just going to narrow it up a little bit. No, I guess I'm not. I'll just go big screen here. We have several parameters that are set up for this job. Sapta, can you read that?
Yeah, I can.
Okay, I need to go zoom in a little more. Okay, so what we're going to do is we're going to indicate by default a parameter that indicates the number of hosts that we're going to use for the next parameter is the cluster that we're going to create, the storage container that we're going to use for the cluster, the input path for an output folder for our MapReduce jobs. And we have a parameter here for our DLL that will be the DLL for the MapReduce job that we just created. We'll then indicate the mapper and the reducer and the combiner. If we only need a mapper, we can provide null values for the reducer and the combiner, but we're going to use everything in here. So to show you how we would actually execute this command, which I have another version of it, we would go ahead and execute the commandlet, and the commandlet I can already see is going to be actually cluster on demand PS. We indicate our hosts. Again, this is just standard PowerShell parameters for our thing where we indicate the name of our cluster and so on, the input path for our file, the output path, and so on. But let's kind of walk through each component of this. So the module name is going to be used to set up, we're going to have to, as part of the script, import the modules. You know, this is assuming that we haven't run this quick test already. So in theory, you should be able to just set up the script to do the execution and run it, but this is designed to run from scratch. So if we go back to the screen here, we need to specify the name of our input path for the commandlets. The other thing that we do is we split out the DLL path and file name that we're going to be used later on for actually, for indicating where our DLLs are with respect to our application. Because if you notice in this chunk of code right here, let me go ahead and just zoom in here. What it's doing is we're going to need the path to the Hadoop client, MapReduce, and web client. Now, when we created our DLL back in census data, right? You'll see here that as part of the application build, we brought in these modules. So when we actually built the project, it took those DLLs over there, and these are supporting DLLs that the MapReduce job is going to need to support the execution of our census data DLL. And so that's why we're doing this add path here. So we're bringing in our commandlets. We're going to go ahead and by doing this add type here, we're essentially importing those libraries into the namespace for our PowerShell. Like we did before, we're going to go ahead and get the subscription info here. So we'll go ahead and get the current subscription where we identify the subname, sub-ID, cert. And we're going to go ahead and set up our storage account. Now I have a little hack in the program right now where the code that's used to run is designed to get the current storage account. But if we go ahead and run this commandlet here, and go ahead and paste, you'll see our current storage account is blank. And so I could actually execute another commandlet to set the storage account, but I'm going to cheat here and actually just set the variable based on my storage account that I want to use here called BD Jumpstart. We get our key information that's going to allow us to establish our secure communications. And I'm hard coding in the password for here. In the example that we're using in the URL for this is that Carl Nolan, who put together this blog post, did a very nice job of using the generate password command here, where it actually generates a 20-character password for this. And this is a preferred way of doing it, but I chose to embed my password here just in case I have problems while the thing's executing. I can go ahead and see what's going on and save myself a little typing. But when you go into production, you'll want to use this method right here. We establish our Hadoop user and our cluster names from the parameters that came in from the application. We set up our cluster URI and our blob storage account, and then we'll go ahead and create our cluster. And so at this point, what we do is we write out our parameters using the right host for the application, and then we'll use the new HD Insight cluster command right here to set up our information. And it includes the default storage account name, the default account key. It needs all this information, include the default storage container, username, password, and all that. Again, these are all the parameters that you saw in the user interface on the first module that we did, where we actually created our cluster. So here we're taking those UI parameters and putting them into PowerShell so we can go ahead and create our cluster. So if we go back here, when this command completes execution, it'll go ahead and indicate that it was created. If something went wrong, it would let us know. The next thing we do is we have a chunk of code here to define our MapReduce job. And so what we're doing is the submitter DLL is the MapReduce DLL that we created, and we're loading in the assembly and then reflecting upon that to get the mapper class name, the reducer class name, and the combiner class. Once we have those set up, we can then go ahead and create a configuration object, and this configuration object allows you to set up a bunch of parameters for running your Hadoop job so that you can limit, you don't have to pass in a whole bunch of strings for it. You create this configuration object as a kind of an ease of use thing. And so you do this series of creating your configuration parameters with your input parameter, your output folder, and then we have some generic things to limit our mapper task to 3. Once we have the configuration object set up, we're going to go ahead and create our URI based on that system, and we'll execute our MapReduce job. And so what we're doing here is creating a variable called Hadoop, and this is a program reference that will set up the connection to our cluster. From there, we'll go ahead and, based on the execution of that, we then will execute the MapReduce job method on the Hadoop object. If everything worked well, there's one more thing we have to do here, is actually this sets up our MapReduce job. We now then, this command right here is sort of the equivalent of the UI that we did when we said in the day 1 module, when we, let's see, or actually in module 2, where we ran the MapReduce job as a streaming job. This thing here, this command here where we're doing the MapReduce job is basically assembling all the parameters to be able to run now our DLL on the system.
Yeah, so what we are doing here is basically setting up the MapReduce job object. We haven't yet submitted it, so it's not yet executioning. We just have the object now all configured up.
Right.
And then we are going to set some environment variables, and only then we will submit it. Is that right?
Yep, that's right. So let's go back to the screen here where I've got our text zoomed. Now there are 2 environment variables that we need to set up, and this is a total workaround right now with the current version of the system, because what's happening here is if you don't set the Hadoop home and Java home when we run this the job.execute method for the mapper, reducer, and so on, what will happen is it'll tell you, hey, you didn't set these environment variables. Now, this reference is mainly for the server. I could have set these to any value as long as it had quote something quote. But this is what would be normally set up on your Hadoop distribution when you're running Hadoop jobs. So the execute method is the thing that actually runs the MapReduce job. So at this point, we've created the cluster. We've now submitted the job, and when that's done, we get back our job ID information. And then finally, to wrap it all up, we'll use the remove Hadoop HD Insight cluster command to actually remove the cluster that we created. Wow, that's a lot of PowerShell script, right? Now it's time to actually get down to running the script. So let's go ahead now and in real time give this guy a go. So let me go back to my cheat sheet here, and for this, actually probably easiest to run through the command. Okay, so here specifically the cluster on demand.ps, this is the name of the PowerShell script that we've created. We're telling it to run with 4 hosts. We're giving it a cluster name, Elastic Cluster, with our storage container of being Hadoop root. I pause. Yep, okay, storage container, good. We have our input path where we're specifying essentially our Hadoop root, which is our default storage, and we're giving it the name of our blob storage account here. We're going to go ahead and create a path called census input, and this is where our MapReduce data, actually all the components that are needed to run the MapReduce job are all going to go up there. We'll have our output folder, and I know I'm forgetting a very, very, very important step here. We have our output folder and we have our DLL. Now, why I'm saying we have our input path. This is where our data needs to be.
Yep. So
right?
you haven't set it up?
I haven't set up our data yet.
Nice.
So I'm glad I kind of paused here for a moment. And so what we need to do is in our Hadoop root storage container, in the census input folder, I need to go ahead and upload that data.
Or you can point it to a folder which already has the data. If
I could, and that's a great idea. So let's see where I put that data, because
glad to be of help.
That might be of help. Okay, so what SupDoc suggested is I go to my storage account here, and we've been using the BD Jumpstart storage account, and in our container we have our working account. And in there, I have my census data files, but what I need to do is I want to get the data files out of this path right here, because this is the only thing that I have my data in. Now this is going to be a little tricky. So I'm just going to go ahead and size the columns here.
Copy it.
And this is where I want to get my data. So I'm going to take this. I'll have to adjust this URL just a wee bit. Okay. Copy that to the clipboard. And now for my input path, I'll go ahead and paste in that value. So let's see, I've got Hadoop root is the name. Actually, it's not Hadoop root, it's working. So we'll go ahead and change our container name to working. And we've got our storage account. We're in our working path, but I don't think I need that working path there. So I'll just go ahead and delete that. The fact that SupDoc's not screaming out is a good sign. And because what will happen is if I mess this up, it'll go ahead and create the cluster, run the MapReduce job, get an error in the MapReduce job, show me that I got the error in the MapReduce, and delete the cluster.
Yeah.
So let's. So we have our input path set now to our data files for the census file. And that path look right to you, SupDoc?
And the output path also exists?
The output path will get created by Hadoop.
Okay.
So we're actually going to create that in the Hadoop root with our DLL. So it should be in Hadoop root.
Yeah, I mean the storage obviously exists.
And then I just need to make sure that this path for the DLL is correct. So I'm just going to go back up to my browser here, and we've got application, census data, and that all looks good. So we'll go ahead and copy that and let her run. Uh-oh. Oh, I'm in this funky state here. Okay. So we have our PowerShell command.
It was the dot in front.
The dot tells it to go ahead and start to load everything in there.
Okay.
Oh, you know, I need to do one more little step. And I hope I have it in my PowerShell thing. So what this basically doing is I have to tell it to execute scripts. I need to tell it that I can execute scripts. And this is going to be a bit of a challenge here. If you bear with me here, I need to, this is a command that everybody that does PowerShell knows, lives and breathes by. Unfortunately, it's escaping my mind right now, and so I've got to go ahead and open up my document. So back to what we were saying earlier, all these modules are going to be available for download either on Microsoft.com download site or through GitHub. And what I need to do is we'll have these hands-on lab modules where you'll be able to copy and paste all this information in. And I'm going to jump down to our PowerShell environment here and find that magical command. You got anything to add there, Septic, while I'm searching? You'll probably go, Bill, you should have known that one. Okay, there it is. We've got to set our execution policy for the script. So go ahead and copy that. And we'll go ahead, and this now should allow us to run our script. I am going to cancel creating a storage account with the password. I think what's going to happen is we're going to get actually this might execute because we already have the modules already set up for the input module. What's happened here is that the commandlets were expected to be in a subpath of what was going on here when I did my parameters. So little fault on myself, but the fact that we're still kind of running means that we're actually executing the cluster. So we can ignore this because way back up here, I actually imported the modules, right? And so what I'd want to do before I put this into production is fix up that input parameter statement that I had here so that I could, that I wouldn't get that error. So hopefully everything's running right. I've got my commandlets that were already imported. If we go back to the screen here down below, I would not have gotten as far as I would have gotten, because if you recall back in our program execution, we're now executing the commandlet to create the cluster. So this is going to probably take
about 10, 12 minutes?
10, 12 minutes, but what I want to do is kind of show you that as it's creating, again, it's going through that same process that we would have normally used through the UI. And if I had paused, if we had BS'd enough here, I could actually, see we're not quite at the step where it's registering it in right here, but I could actually, for example...
There's a job running. Can you click on that little...
this is probably from the prior step where I did this. But one of the things I can do is, if you recall, when I go to actually manage a cluster here, I'm going to take this URL, and if I change this to Elastic Cluster, I think this was a name. You see, it's still, what would happen...
Wasn't it just Elastic?
Oh, actually, why don't I go back to our code? So it was called this guy right here.
Elastic Cluster.
Right. So what would happen is that when I'm actually, when the cluster gets created for the short time while the job's running, I could actually go in here and connect in and see what's going on, right? But at this point, it's not quite there yet.
Yeah.
And what would happen is that when it does get there, oh, look at that.
Yeah,
how cool is that? We're in the HD Management Console, and we can see that we're already progressing here with the VM configuration. So after the VM configuration, it'll go ahead and do the Hadoop cluster. I think at this point, I think what we'd like to do is pause so that, and we'll wait till we go ahead and get our cluster up and running. And
till then, let me quickly explain what we did in this PowerShell script. So in this PowerShell script, as you know, if you listen to or watch the first module, we talked about how the storage accounts and the cluster, which is the processing resource, are kind of not tightly coupled. So one can exist without the other. So you have your files that you want to process, or your data that you want to process in the Azure Blob storage. Now, the point is that you don't need to keep your cluster around, which are the processing resource around when you are not processing the data. With this script, what you can do is you can automate the process of creating a cluster of a size of your choosing, do the processing by the job that was submitted, and once the job submits, you can remove the cluster. So this single command that Bill entered is going to go through all the process of submitting execution task, which creates the cluster. It's going to then submit the job, which processes the files, stores the results back into the blob store, and then delete the cluster so that you are not incurring cost of the cluster resources.
Okay, so our PowerShell script has executed. If we go back to the screen here, what I just want to show is you can see where we used to have the Elastic cluster. It's already gone, so the cluster got deleted. The way that we can tell what happened is by going to our storage tab now, and if we go ahead and look in our BD Jumpstart and in our container, if you recall, we set up back to here, we set up our output location as our Hadoop root census data output. And so if I go back now to our storage module and under Hadoop root, this will go ahead and enumerate the data. And we'll see here we have our census data output folder, census output success, and our part file, which has our data in it. And so I could go ahead and view this data or whatever. This will essentially be the same output result that we had with our MapReduce job that we ran in Module 2. So that's it.
Yeah. So essentially, in one fell swoop command, he created a cluster, ran a job, deleted a cluster out of it, right?
Yep. And so the data is sitting on the
data
Azure
is
storage.
still there.
Yeah.
Right.
Really
That's
cool.
awesome. So in this module, we saw how to manage data using Web Hdfs API. We saw how to trigger off jobs and manage jobs using Web HCAT. And finally, we saw how you can use PowerShell to automate this all this without writing .NET code, just from PowerShell and automate the entire process end to end. So that's the end of our day one training here. Yeah. We're getting started with Microsoft Big Data. I hope this was useful to you. We do want to follow up with another day of content.
Yeah, around analytics.
Where we show you more around big data analytics. And thank you so much for watching. And thank you, Bill, for
You're welcome,
presenting.
Satya. It's been a lot of fun. Thanks.